Section 5.2, Polynomials, Linear Factors, and Zeros. The objectives are to analyze the factored form of a polynomial and to write a polynomial function from its zeros. Finding the zeros of a polynomial function will help you factor the polynomial, graph the function, and solve the related polynomial equation. Problem 1, we're looking for the factored form of x cubed minus 2x squared minus 15x. So what you look for first is to take out as much as you possibly can. This time the only thing we can take out is an x. And then you have to write what's left in parentheses. So x cubed, if you take an x out, you have x squared of them left. Make sure that you remember that you are subtracting the exponents here. When you take an x out of a negative 2x squared, you have one of those left, along with the 2. And when you take the x out of the negative 15x, you get negative 15. Then you look at the parentheses again and see if you can factor that one more time. We are looking for factors of negative 15 that add up to negative 2. The highest one has to be the negative because the middle one is negative. So x minus 5 and x plus 3. We need one of each sign because of the negative at the end. That is your factored form. When it says factored form, do not solve. The roots, zeros, and x-intercepts. This funky polynomial equation right here is just like the one that we did, except that it's equals to something. X minus b is a linear factor of the polynomial. So those factors that we got at the end of this one, for instance, x minus 5, and x plus 3, those are all x minus b's. When you actually solve that equation, x minus b equals 0, you get x equals b. So that's turning it from a factor into a solution. Another name for solution is root. And then the last one, those places that you solve are actually solutions or x-intercepts. Problem 2, what are the zeros of y equals x plus 2 times x minus 1 times x minus 3? So what we're going to do is set this equal to 0. We're going to solve each one by setting each part equal to 0. So we get x equals negative 2, x equals 1, and x equals 3. We're going to put those on the graph. So one point is at negative 2. Another point is at 1. And the other point is at 3. Next, step 2 says find the points for the x values in between the zeros from number 1. We already know what's going on to the left of negative 2. We already are going to know in a minute what goes on at the right. So we are concerned with the ones in between. So we need to pick a point between negative 2 and 1. You can do this in a little XY table if you'd like. I like to go with something that's about halfway there. But I'm going to choose either 0 or negative 1. So let's go with negative 1. And I'm also going to choose something between 1 and 3. I usually try to go halfway, so I'm going to choose 2 for that one. And where we're going to plug it into is the original factored form. So y equals x plus 2, x minus 1, x minus 3. So if I plug -1 in there, -1 plus 2 would be 1. -1 minus 1 would be -2. And -1 minus 3 would be -4. So my number is 8. I'm going to plug a 2 in there as well. So 2 plus 2 is 4. 2 minus 1 is 1. 2 minus 3 would be -1. So here I get -4. What those points do is it kind of tells you what's going on in between them and what direction this graph is going to go. So at 2, -4, I'm going to put a point, and at -1, 8. I'm going to put another point. Now we need to talk about the end behavior. With this one, we are given the factored form, which is down here. And it doesn't give us that highest exponent. But if you think about the x's, just the x's alone, if you multiply this x times this x times this one, wouldn't you come up with x cubed? And it would be positive since all of them are positive. So here we have an equation that is positive and odd. So you're going to have a down-up scenario. So we are going to draw these in now. We're going to try to make them kind of smooth. And the end result kind of looks like that. So the factor theorem basically tells you that x minus a is a factor of the polynomial if and only if the value a is a 0 of the related polynomial. What we're going to do is we're going to try to figure out these problems backwards, going from the answers to the equation. So with this one, we have an x equals -2, and we have an x equals 2, and we have an x equals 3. So we need to turn them into factors, so we're going to subtract or add, depending on what you're doing, and set it equal to 0. So on the first one, we're going to add 2 to both sides, which makes it x plus 2 equals 0. On the second one, we'll subtract 2, which makes it x minus 2 equals 0. And the third one will also subtract. Our factors then are x plus 2, x minus 2, and x minus 3. Set it equal to 0. What we're going to do is we're going to just multiply 2 of these at a time. And then we'll take that answer times x minus 3. So x plus 2, x minus 2, if you use FOIL, looks like this. X squared, the outer terms would be minus 2x. Inner terms would be plus 2x and minus 4. And we haven't taken care of that x minus 3 yet, which we will do in a second. X squared, the middle terms actually cancel, and you get minus 4, and then times it by x minus 3. FOIL again. So x squared times x would be the first terms, would be x cubed. X squared times -3 would be your outer terms. -4 times x would be your inner terms. And -4 times -3 would be positive 12. And that is your function. So instead of putting it equal to 0, I'm going to put it equal to f of x. So if we turned around and factored this thing out, which you guys don't really know how to do yet, we would get -2, 2, and 3. Also, this one was a cubic polynomial, so your highest exponent should have been an x cubed, which it is. The next one tells us they want a quartic, which means the highest exponent's going to be a 4. And you can see that there are 4 answers here. X equals -2 twice. X equals 2. X equals 3. So we'll turn them each into factors. which gives us x plus 2, x plus 2, x minus 2, and x minus 3. You can really do these in any order that you want to. We have already multiplied x plus 2 and x minus 2, and we know that it gives us x squared minus 4. Anytime you have signs that are different in the middle, but the numbers are the same, those middle terms are going to cancel. The next thing I'm going to do is multiply these two, because I already know that I can do those pretty quickly without too much work. And that gives me x squared minus 3x plus 2x minus 6. And we still need to do x squared minus 4 here in a minute. So that gives us x squared minus x minus 6 times x squared minus 4. The last part isn't really FOIL, it's kind of an extended version. Basically, you're going to have 6 terms left. You're going to take x squared times each of the terms in the first parenthesis and a negative 4 times each one. So it's kind of like you're using distributive property. So x squared times x squared would be x to the 4. X squared times negative x would be negative x cubed. X squared times negative 6 would be negative 6x squared. Now we'll go to the negative 4. Negative 4 times x squared would be negative 4x squared. Negative 4 times x would be plus 4x. Negative 4 times negative 6 would be plus 24. And then we simplify, and then we are done. The only two that can be put together are those two. And there is your quartic function. And look, we did get x to the 4th as our highest exponent. Now, it says to graph both of these functions here. What I'm going to do is I'm going to talk about I'm going to do one of them. And I'm going to talk about the multiple zeros. I knew I had skipped that page. If a is a zero of multiplicity n, in the polynomial function y equals p of x, then the behavior of the graph at the x-intercept will be close to linear if it's n equals 1, close to quadratic if n equals 2, close to cubic if n equals 3, and so on. A zero of multiplicity n means that x minus a appears n times as a factor. So, on problem 4, what are the zeros? So we set it equal to 0. On this one, we can take an x squared out, and we're left with x squared minus 2x minus 8. Remember to subtract those exponents. We're still going to factor the parentheses, which means factors of negative 8 that add up to negative 2. X minus 4, x plus 2. Oops, we want to solve this time. They want to know the zeros. So 1 0 is going to be x squared equals 0, which means x equals 0. The other is going to be x minus 4 equals 0, or x equals 4. And the other one's going to be x plus 2 equals 0, or x equals negative 2. Now the next one says, what are their multiplicities? So what we want to do is we want to look at the factored version of this one. And what we want to do is we want to write each answer, x equals 0, x equals 4, and x equals negative 2, with a multiplicity behind it. The multiplicity is basically the exponent with that factor or that 0 brought. So with the 0, you are looking at this term right here. Oops, let me put that off to the side. X squared. Notice there's a 2 on there. It is multiplicity 2. Notice the x minus 4 didn't have a number, so it's a 1. That's a multiplicity 1. The x plus 2 Didn't have a exponent either, so that's a 1, and it is a multiplicity 1. Now, what that means is when you are looking at multiplicity, if it's even, it's going to do a specific thing. If it's an odd, it will cross or touch the graph. So when it's odd, it's going to cross the graph through those points. If it's even, it's going to touch it, and it's going to go up the other way, up the same way it came. So we're going to put these zeros on the graph, 0, 4, -2. And then we're going to kind of discuss the multiplicity and how that works. So 0, -2, 4. Okay, so there's my zeros. I'm going to do the multiplicity first. So we decided that it's going to touch at 0 because it's even. It's going to cross at 4, and it's going to cross at -2. Okay, so we'll have those taken care of. We're going to find some points in between, just like we did on the last graphing question. And I just need to look at my factored form. X squared, x minus 4. And x plus 2. Okay, so we're plugging our numbers in there. We need 1 point between -2 and 0, so I'm going to choose -1. And we need 1 point between 0 and 4, and I'm going to choose 2. So when I plug in those two numbers to this equation I just wrote down, I get -1 squared, which is 1. -1 minus 4 is -5. And -1 plus 2 is 1. So I'm going to graph it at -5. So I'm going to put that point in here, 1, 2, 3, 4, 5. And then I'm going to plug a 2 in there. I get a 4. And I get a -2. And I also get a 4. So that would give me -32. Okay, so -32 is really far down there. So I'm going to put an arrow and I'm going to put -32. We'll kind of get the idea. When we multiply all of these x's out, just like we did on that last one, we have x squared right here. We have an x right here. And we have another x right there. When we multiply all those, we're going to get an x to the 4th, and it will be positive once again. So this graph is going to be positive and even, which means you have up, up. So on the left sides, left and right sides, it's going to be going up. We're going to start up here, come through this point. So it crossed that first point. We're going to go to the next one. And at 0, it's going to touch. So what we're going to do is we're going to draw it up to 0, and then it's going to come back down. And it's going to go way down to -32. And then it's going to turn around and it's going to come back up. And then it's going to go up on the right. So basically, those points in between describe where it's kind of going and where it turns. The zeros kind of tell you, does it cross through the point or does it touch the point? And we are skipping this one.